I really feel fascinated about sharing a little bit of understanding that I have regarding carbon nanotubes. These tiny structures, uh, they have captured the attention of scientists and engineers worldwide, revolutionizing various industries and opening a gateway, uh, new doors to the technological advancements. So these carbon nanotubes, they're often abbreviated as CNTs. CNTs. They are cylindrical in structure, and entirely made of carbon atoms. Uh, so 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 these carbon nanotubes, everything that's there in these carbon nanotubes is the presence of carbon atoms. And suppose we roll a single sheet of carbon atoms. If we can have a single sheet of carbon atoms? We call it graphene. And if we roll this graphene into a cylindrical geometry, uh, and and that's what makes a carbon nanotube. So, carbon nanotube is basically the cylindrical geometry of graphene. So everything that's there in carbon nanotubes, it's all having carbon atoms in it, and they have unique properties. They have very unique properties due to their size, because the size is what makes them different from that of graphite or diamond out there in the form of bulk matter. Uh, s- and this these carbon nanotubes, they have exceptional strength and remarkable electrical and thermal conductivities. So, to be precise here, that what is a carbon nanotube? It is basically when you translate a two-dimensional carbon sheet into a cylindrical shape, it forms a carbon nanotube, and certainly it has the exceptional properties. And these exceptional properties are numerous uh, uh, when it comes to the application of these carbon nanotubes. The very first important thing is that these cylinders, these carbon nanotubes, they are incredibly strong. They are very, very strong in comparison to the steel. And at the same time, they are very light. Their weight is very less. So this property makes them attractive. This property makes them attractive for use in aerospace and automotive industries, to create lightweight yet robust materials. Okay, so the next important thing regarding these carbon nanotubes is that these carbon nanotubes have excellent electrical conductivity. Okay, and this makes them ideal for electronics and advanced nanoelectronics devices. Moreover, their thermal conductivity has potential applications in thermal management and the dissipation of heat. Okay, so there are many more things that we can talk about in terms of their properties, like electrical and thermal conductivities. So if I have to make a small differentiation here, is that the amount of current that we can pass through the copper wires or aluminum wires, and through carbon nanotubes. Certainly, there are the experimental outcomes that are dictating us that the conductivities of these carbon nanotubes are far more better than that of the conventionally available bulk materials of copper or aluminum. And the next important parameter that's linked with these carbon nanotubes is the energy storage. No doubt we have solar panels, but we don't have the efficient batteries. So if we don't have efficient batteries, if we don't have efficient energy storage, then certainly the outcome of the technology is not going to be to the level where it should be utilized to the large masses. These carbon nanotubes have been explored for use in energy storage devices. They have been used in batteries that I was talking about, and supercapacitors as well, where you can have large quantities of storage of charge and energy. This is the result. This is the result that's very attractive when it comes to investigate more and more carbon nanotubes. Not only investigate it, but to design more preferable geometries that can give an outcome of more and more storage. And then there is another important application of these carbon nanotubes is they can be used as sensors. Okay, so they are certainly excellent candidates for gas and chemical sensors due to their sensitivity. Certainly, so they are more sensitive because they are there in the domain of nanoscale, and at nanoscale we know that the ratio between area and volume goes on decreasing. Or in other words, I should say that the exposed area of the material is large in comparison to its bulk format. So this sensitivity of these carbon nanotubes, it makes these carbon nanotubes a very excellent candidate for sensing the gas or chemical substances. And medical applications. Certainly, it does fall in the domain of medical applications. Uh, Before everything, whatever is nano can have tremendous applications in medical science. And research is underway in this domain to explore the potential of carbon nanotubes in drug delivery systems. Suppose there's a problem somewhere in vicinity of some organ. What could be the most feasible way to transport the drug to the affected area without actually affecting the other domains of that organ or the vicinity of that organ. So these carbon nanotubes can be the potential candidates to carry the drug to the point or where this drug is supposed to go and supposed to interact with atoms. And lost, certainly every technology that's out there, from nuclear energy to artificial intelligence, to any advancement. Certainly, you don't have the positive side of that technology always. There are potential dangers also involved in that technology. This technology can go in the wrong hands. This technology can be used in wrong ways. So there are challenges. There are challenges to make more sophistication, to actually come to a state where we can commercialize these carbon nanotubes. So while carbon nanotubes hold immense promise, some challenges must be addressed before their widespread adoption. What are these? These include scalable synthesis. Till now it's out there in the laboratories in the form of very very minute samples. Those minute samples have to be replaced by scalable synthesis, where a good amount of these these carbon nanotubes are produced, ensuring uniformity in their properties. So it should not be that one laboratory will report that it has these kind of beautiful things in it, and the other laboratory reports in the negative direction. So there is a need of attaining that uniformity regarding the outcomes of these carbon nanotubes. As researchers continue, they continue to develop novel applications and overcome existing challenges. And we can expect to see their integration into various industries, and further revolutionizing the technology and engineering. So, in conclusion, carbon nanotubes are a remarkable example of how nanotechnology has the potential, the possible potential to reshape our world. Their unique properties and versatile applications make them a key of focus of research and development. So, as we explore their potential, it is always essential to do so, so that opportunities they offer and work towards a future where carbon nanotubes can contribute to the sustainable and innovative solutions. So this is what I had to share with you. I hope you find it